Hi guys, tonight we're going to take a look at another measure of spread. We've looked at range, we've looked at mean absolute deviation, and today we're going to look at standard deviation. And this is something that might be new to you, so pay attention. Okay, what does the word standard deviation mean? And standard deviation is just the act of departing from the established course or accepted standard, and in math that means the amount a single measurement differs from a fixed value such as the mean. So for example, here's our mean, and we're trying to figure out how far, just like with mean absolute deviation, are our points from the mean. And so this is the symbol that is used for standard deviation, and yet again here is another symbol that is used for mean. We've used the x bar, but in the standard deviation equation we use that little symbol, and I'm pretty sure it's called a mu, but I'm just going to have to double check on that. So this graph here is called a normal distribution. It's a normal curve, high in the middle and low on the ends. Sometimes it's also called a bell curve, and you'll learn more about the bell curve in CCM 3. And so the shape of this graph, as we can see, is mounded or symmetrical. And this bell curve is used for a lot of things. When we talk about IQ, there's the bell curve. When we look at grades, there's a bell curve. So the general summary statements that should always be written in context about standard deviation. So the data varies by about whatever data we're talking about, how many standard deviations from the average of the mean. And the data typically varies from about the mean, which is the center, minus one standard deviation, and we're going to figure out what that number is, to the mean, well, here's the minus, plus one standard deviation. So the majority of the data set is between how many standard deviations. So if we look at this data set here, whatever this data is measuring, the majority of our data is between one standard deviation of the mean going this way and one standard deviation going that way. So about 68% of the data is within one standard deviation of the mean, meaning it's one standard deviation more or one standard deviation less. If the standard deviation is 0, this indicates that every data value in the set is the same. So if we don't have a standard deviation, that means none of the points deviated from the mean, which means they were all the same. So these bolded or underline words are what we will fill in once we figure out what our standard deviation is for a set of data that we're going to work on in class tomorrow. So one thing to note about the standard deviation, the smaller the value, the closer the data is to the mean, which means the data is more consistent and not as spread out. And the opposite of that is true. The larger the value of the standard deviation, there's more variation and the data is more spread out. So in class tomorrow we are going to do standard deviation by hand, but it can also be done on the calculator. And so I'm not going to do this on the calculator, but you can follow along on yours. The first step is to enter the data into list 1, so 28, 48, 53, 25, 38, 23, 49, and 32. And we've done all this part already. Press stat, arrow over to calc, and it's one variable statistics because we're only putting it in list 1. And then we hit vars, one variable statistics. We get this bevy of information right here. And we've talked about this before. This arrow down here means that there's more data down there. And when we're looking for standard deviation, we are looking for two notations. This one, which is S of x, that's our sample deviation, and this one, which is our population deviation. And for our purposes in class, we will be using sample deviation for standard deviation. And this is used more frequently because in order to use population deviation, we need to have an entire population, and that's not often the case. So we're going to use this function on the calculator to answer video questions 1 and video questions number 2. What is the sample standard deviation for the data? So we are looking for S of x of this set of data right here. Then fill in the blanks, use the general summary statements from your notes, round to the nearest tenth. So the majority of the data is between which two standard deviations. So keep in mind it's going to be the mean minus 1 standard deviation and the mean plus 1 standard deviation. And where do you get that standard deviation? You get that from that question right there. And again, if you have questions, just fill them out on the question form.